All right, welcome back, ladies and gentlemen, which from what seems like a very long but well-needed break. We're going to start this fourth marking period here with lesson 9.1 on solid figures. So our job today, our goal is just to identify and name solid figures. So let's go through some of the vocabulary that we have here. The first thing is when we talk about solid figures, we're just referring to three-dimensional shape. So my coffee cup is an example of a three-dimensional shape. Your desk is a three-dimensional shape. Our world is three-dimensional, and so we're going to start looking at how we define and look at some of these three-dimensional shapes. A polyhedron is a solid, so it's a three-dimensional figure that's formed by polygons. So we've just studied polygons, so those are things, these are going to be solids that are formed by triangles, rectangles, squares, trapezoids, formed by hexagons, octagons. A basketball would not be considered a polyhedron because it is round. But what you are going to see is there are some solids, some three-dimensional figures that are going to surprise you that actually will be polyhedrons. But like my coffee cup, because it's curved, it's not considered a polyhedron. Face, the polygons that make up the surfaces of the solid. So when we talk about the faces of a polygon, when we think of a box that we get in the mail, that we ship something in, the rectangles that make up the surface of that solid are called the faces. And then the edge are the segments that join the vertices and faces. And so you're going to go through today and you're going to look at naming faces, naming these polygons that make up the sides, and then the segments that join them, where you kind of see the joint or the of the sides. All right, so example 1, identify and name polyhedrons. Tell whether the solid is a polyhedron, describe the shape of the base, and then name the solid. So we look at A. A looks like a wedge of cheese. Everything's straight, cut. And then we look at B. B is what we would call a cylinder. So it's got that curve to it. So the solid in A is formed by polygons. All of those are either rectangles or triangles. And so because all of the sides are formed by polygons, it is a polyhedron. So we're taking that polygon, stretching it to 3 dimensions and calling it a polyhedron. The bases are what we would call congruent triangles. So we have a triangle here at the top, a triangle here at the bottom. And the bases are parallel. So when we start to try and identify the bases, they're going to be the parallel ones. That's why these rectangles on the side cannot be the bases because they all intersect. And so this is what we call a triangular prism. And so we saw some of those with the video we watched, and then we'll also introduce some more careful explorations of prisms and what the exact definition is. But because it has triangles that are parallel from each other making the bases, we call that a triangular prism. The cylinder has a curved surface, as I mentioned. So because it is curved, it is not a polyhedron. Now that doesn't mean we're not going to work with cylinders, because we're working with solids, three-dimensional figures, not just polyhedrons in this chapter. So we will learn some of the characteristics and how to do some calculations with cylinders. All right, so now what we want to do are find the faces and the edges. So we want to name the polyhedron at the right, count the number of faces and edges, and then list any congruent faces and edges. So the solid has one base. Everything comes to this point, so I know that there's only one base. And the shape of the base, if we look at it, it has 1, 2, 3, 4, 5, 6 sides. I'm going to erase those green marks because they've already put congruency marks there. But it has 6 sides, so it's a hexagon. So the polyhedron is what we would call a hexagonal. And this is a pyramid. think of like the pyramids in Egypt where they come to the point at the top, a hexagonal pyramid. All right, because it is a hexagonal pyramid, that means it has 6 sides around the top, one from each of the sides of the base, so there's 6 faces there. And then it has 1 for the base. So it has a total of 7 faces, 1 for the base, and then each edge of the base creates another face. And then when we talk about the edges, well, if there's 6 edges along the bottom, so there's 6 from the edges of the base, and then there's going to be 6 coming from each vertex, so 6 edges from the vertices for a total of 12 edges. So each side of the base is going to create an edge. So if we think of this as the 2-dimensional figure that we studied in chapter 6 and in chapter 8, creates an edge. And then from each of those vertices, there's going to be another edge. So we have a total of 12 edges. We want to talk about the congruent faces. Well, because each of these sides on the hexagon is congruent, so our base is a regular hexagon, and each of these sides, if we see, are marked as being congruent, so each of these edges are marked as being congruent, that means every face around the sides of that pyramid are congruent. So we know that triangles, if we kind of go around the edge of it, we'd say PQV, so PQV is congruent to triangle. We'll go around QVR. Actually, I need to, if we want P to Q, I need to go Q to R. So QRV, this vertex at the top of the pyramid, is going to be our last letter, is similar to triangle RSV. S goes to T here, so this is triangle STV. T goes back to U, so triangle TUV, and then U goes back to P, so triangle UPV in there. And then the congruent edges are just every segment around the base. So PQ is congruent to QR, is congruent to RS, so we can see all of these are congruent. So they named those 6 congruent sides. And notice they stop because now we have the edges coming up from each vertex as being congruent. So PV is congruent to QV, is congruent to R to V, SV, TV, and UV. So we're using those congruency marks the same way we did before to create congruent faces, congruent sides of the figure, as I call them many times, and then the edges. All right, so now we're going to take a look at sketching polygons, or polyhedrons, I'm sorry. So we want to sketch a triangular prism. So if it's a prism, that means it has 2 bases. And they're going to be triangles. So we're going to draw 2 congruent triangular bases. So I'm going to draw a triangle here in the front, and then I'm going to make one that's parallel to it here. So I'm drawing a little bit farther back. We could draw one up here and one down here. They could go vertically, kind of horizontally like that. Now we're going to connect the corresponding vertices. So top to top, left to left, right to right. Here I could do, once again, top to top, left to left, right to right. And then we want to erase any of the partially hidden lines. So when I look at this figure here, I'm going to see everything in the front, I'm going to see everything here on the side, and I'm going to see this, but I'm not going to see the back here. So this is going to become kind of a dashed line here. I'm not going to see this, so that becomes a dashed line there. Now these are still full lines that I can see. And I'm not going to see this here, so this becomes kind of more of a dashed line there. So those are the parts we can't see. On this one, if I'm looking down at it, I'll see all the front. I'll see the sides here, and I'll see, but I won't be able to see kind of the back here. So we have dashes there, connecting these, being hidden. This is a solid. This is dash here because we don't see the dashes there, but these are solid connecting those. All right, so we want to be able to put those dashes in to show that those aren't visible to us, but they're still part of it. And then they want us to shade the prism, so shade the front of it. So the front of it is this. This is the front of our prism. Here, this would be the front of our triangular prism there. All right? So that's what we're going to do here. We want to sketch each of the following below. We want to sketch rectangular prisms, triangular prisms, and a cube. Well, this means I have two rectangles. So I'm going to draw a rectangle. I'm going to draw a rectangle. I'm going to be able to see this. Now, if I go back, I'm going to kind of, I'm not going to be able to see all of this. I'm going to make that dash. I'm not going to be able to see all of this, so I'm going to make this dash. I'll be able to see all of this as I'm looking at it. I'll be able to see all of this, but this I won't be able to see, so I'm going to put a dash in there. We've already drawn a triangular prism, so I'm going to let you guys do that one on your own. And then a cube is just with squares. So it's the same thing that we just created for the rectangular prism, except you're going to have 6 squares. All right, which means when we start with our 2 squares, the distance should be this same length here. So this length here, my square, should also be the length I'm going back here. So we have a square there at the top. I'm not going to be able to see this side. I'm not going to be able to see this side, and I'm not going to be able to see this side, but I can see this side and this side. So a cube is just 6 congruent faces for that. When we take a look at pyramids, remember pyramids, my pages are a little out of order. Pyramids just mean that there is one base. So we're going to have a rectangular pyramid, which means we have one rectangle. So we're going to have one rectangle. And from each of those comes a, up to a vertex. All right, I should have created a dash here on the back side because we're not going to be able to see that. So we go through and do that. Let's draw our rectangle here and then put the dashes there because we're not going to be able to see that. Draw this up, the front, and the side here, you'll see those. And so those come up to there. We don't really see the back side of that rectangular pyramid from there. Triangular pyramid means you have a one triangle, and you're going to have 3 lateral faces. So I'm going to let you guys do that one on your own. And pentagonal just means you have a pentagon. So we have a pentagon, a 5-sided figure. All right. This one's a little bit more difficult. I'm going to try and notice pencils are nice, so we're going to try and then we want to put some dashes in there. Draw those out to the top. We're not going to see. If we're looking down on our pentagonal pyramid, we would do that. If we're looking down on it, we would see all of those. If we draw a pentagon, make those kind of dashed. We have that coming from the front. We would draw those up a little bit higher. And then this would be dashed in the back. and then coming from the side. But because there's 5 sides to a pentagon, we should have 5 edges to the top. So I have 1, 2, 3, 4, and then 5 is that dash line at the back. But you need to do the triangular pyramid on your own. Now we have one more here. Cylinders have, it's like a prism. We have 2 circular bases. Now for this one, I'm not going to see the back side of the circle, but I will see the front of it. And then we have the sides coming down, so that's a cylinder. Circles are my difficult ones to draw. It's a little bit easier if you draw 2 circles and then can erase that. So if we draw 2 circles and then draw 2 circles, you can have a candle on that side. And then can I go through there and do some dashes there? And then connect those. And so, let's see this side of it. A cone, it's like an ice cream cone. You've got a circular base, so you've got a circle. And you've got the back side that you don't see. And it comes up to a point, like a pyramid. And then a sphere is almost like 2 circles. You've got a circle going this way. And then to show that it's a sphere, we're going to come out. And then we're going to dash around the back side. So that's what our spheres will look like. Okay, so you guys got a couple to do on your own. Let's take a look at the checkpoints. Tell whether it's a polyhedron. If so, identify the shape of the base or bases and then name the solid. So for number 1, I'm going to have you guys do this one on your own. You guys have some examples to look back at in your notes, so find that in your notes. Number 2, you guys should be able to find that in your notes, but think back to your definitions. Number 3, so this isn't on your own, you guys should be able to look back and name those, and then use your definition of a polyhedron. Number 3, we will do together. Number 3, there's only one base. Everything comes to a point, so I know it's a pyramid. When I look at the base, it's 1, 2, 3, 4 sides. So it's a rectangular. Oops. Those are going to be stuck together. So I'm going to have to rectangular pyramid. Now, what I was supposed to do was tell whether the shape is a polyhedron, because I can see 4 triangles and a rectangle. Yes, it is a polyhedron. The base is the rectangle. And so then that led me to naming it. All right? So you guys should have answers here of 1, 2, and 3. Yes or no? What's the base? And then what is the name? All right? Enjoy and have a good evening.